Time defines our lives. It tells us when we are born, how we grow, and when everything must end. For centuries, we believe time flows forward, 1 second after another. Unchanging, universal, absolute. But modern physics tells a very different story. According to Einstein's theory of relativity, time does not move at the same speed for everyone. The faster you travel, the slower time passes, and the stronger the gravity, the more time bends. Astronauts aboard the International Space Station age slightly slower than people on Earth. Particles moving near the speed of light experience almost no time at all. At the deepest level of reality, time begins to lose its meaning. In quantum physics, the equations that describe the universe often work without time. Some theories suggest that past, present, and future may exist simultaneously. What we experience as the flow of time may be created by memory, motion, and change, not by time itself. If this is true, time may not be fundamental. It may be an illusion created by the way we observe the universe. A useful illusion, but an illusion nonetheless. So, the next time you watch the clock, remember, time may not be moving forward. Time feels so personal, doesn't it? We can almost sense it in our own heartbeats. In every breath we take, we feel it in the way our bodies wake with the morning light and slow down as night arrives. From the moment we're born, time starts shaping who we are. We grow, we age, we remember. But how we humans actually experience time isn't just about what the clock says. Inside our own brains, time is surprisingly flexible. Think about it. Moments that are packed with emotion can feel like they stretch on forever, while routine days just seem to disappear in a flash. Waiting for something makes time crawl, but looking back, years can feel compressed into a single memory. This is what we call psychological time, and it's created by our attention, our emotions, and our memories. Biologically, our bodies are running on all sorts of internal clocks. Our circadian rhythms tell us when to feel awake or tired. Hormones rise and fall with the cycle of day and night. Even our heart has its own steady rhythm. But here's the catch. None of these systems are actually measuring time itself. They're measuring change. We don't experience time directly. We experience things moving, growing, and aging. We see cause and effect. Clocks are just tools we invented to organize society, and schedules help shape our lives. But that deep feeling of moments passing, that's created right inside of us. Time feels fast when life is full, and slow when we're still. It feels heavy when we wait, and light when we forget about it completely. So, in our daily lives, time isn't some external force pushing us forward. It's a story that our minds and bodies are telling us, moment by moment. And maybe, just maybe, understanding that can change how we choose to live within it. For most of human history, time seems simple. Early science viewed time as absolute. It flowed forward at the same steady pace everywhere in the universe for everyone. In classical physics, space and time were separate. Objects moved through space while time marched on independently. This view shaped the foundations of science. Motion followed clear rules. Forces produced predictable results. If you knew an object's position and speed, you could calculate its future with certainty. Time, in this framework, was universal. A second on Earth was the same second anywhere else in the cosmos. Clocks were trusted, timelines were straight, the universe was seen as orderly, mechanical, and predictable. This idea of time worked remarkably well. It explained falling objects, moving planets, and the motion of everyday life. For centuries, absolute time was not questioned. It felt obvious, intuitive, common sense. But beneath this simplicity, a deeper reality was waiting, one that would eventually challenge everything we thought we knew about time. At the beginning of the 20th century, Albert Einstein changed how we understand time. In his theory of relativity, time is no longer absolute. It depends on motion and gravity. As objects move faster, time slows down. At speeds approaching the speed of light, seconds stretch, and clocks tick more slowly. Gravity also affects time. The stronger the gravitational pull, the slower time passes. This is not science fiction. It happens in the real world. Satellites orbiting Earth move faster and experience weaker gravity than we do on the surface. As a result, their clocks tick at a different rate. Without correcting for this time dilation, GPS systems would drift by kilometers every day. Relativity is not just a theory. It is built into the technology we rely on. Einstein showed us that space and time are woven together, forming a single fabric called space. Time bends, time slows, and the universe reveals itself to be far more flexible than classical physics ever imagined. In modern physics, space and time are not separate. They are woven together into a single structure called space-time. Every object in the universe moves through this fabric, not just through space, but through time as well. When a planet or star exists, it does not simply sit in space. Its mass bends the fabric around it. Gravity is not a force pulling objects inward. It is the curvature of space-time itself. Light follows these curves. Time follows them too. Near massive objects, time slows, paths bend, straight lines disappear, and on the largest scales of the cosmos, space and time become inseparable. They shape one another constantly, everywhere. The universe is not a static stage where events unfold. It is an active, flexible fabric, and time is stitched directly into it. Have you ever wondered if the clock on your wall is lying? What if I told you that at the deepest levels of reality, time might not even exist? Let's dive into the weird world of quantum mechanics. Down at the smallest scales, things get strange. Particles don't travel in a straight line. They're more like clouds of possibility. They pop in and out of existence, existing everywhere at once until we look. Now, here's the really mind-bending part. The fundamental equations that describe this quantum world don't always need time. They describe relationships between things, not a sequence of events. Cause and effect, the very things that define our experience of time, can get blurry. In this view, the universe isn't a story unfolding moment by moment. It's a single, complete structure that just is. So, where does our feeling of time passing come from? It might be an emergent property. Think of it like temperature. A single atom doesn't have a temperature, but a group of them does. Similarly, time might only appear when countless quantum events interact, creating the flow we experience on our human scale. So, the universe might be fundamentally timeless, and what we call time is just our unique, large-scale perspective. One way scientists think about time is known as the block universe. In this model, the universe is a complete structure. Every moment, past, present, and future exists together. Nothing flows. Nothing moves. Time does not pass. What we call the present is simply where our awareness happens to be. Other scientists disagree. They argue that time truly flows, that the present is real, the past is fixed, and the future is open. In this view, the universe unfolds moment by moment. Physics allows for multiple interpretations. Some fit naturally with relativity. Others reflect how time feels to us as conscious beings. So far, no experiment has ruled one out completely. Time may be a static structure, or it may be a dynamic process, or it may be something deeper that we have yet to fully understand. For now, the nature of time remains an open question, one where science and philosophy meet. Have you ever felt like time was flying by, or maybe dragging on forever? It makes you wonder, is time even real, or is it just something our brains made up to make sense of the world? Some physicists and philosophers actually argue that our common sense idea of time a river flowing from the past through the present and into the future is totally wrong. They suggest that the past, present, and future all exist simultaneously. Think of it like a movie reel. Every frame, every moment is already there. We just experience them one by one. This idea comes from Einstein's theory of relativity, which shows that time can stretch and shrink depending on how fast you're moving, so my now might be different from your now. What if the universe is just a collection of countless nows, all existing at once? It's a mind-bending thought, isn't it? What do you think? Modern science measures time with astonishing precision. Atomic clocks tick billions of times per second, keeping time so accurate that they would lose less than a second over millions of years. Deep space observatories track pulsars using distant stars as natural cosmic clocks. Quantum technologies allow us to probe time at scales once unimaginable, observing the vibrations of single atoms and subatomic particles. These experiments reveal that time is not merely a human construct. It is intertwined with motion, gravity, and the very fabric of the universe. By measuring time with extreme accuracy, we not only coordinate our technology, like GPS and telecommunications, but also explore the fundamental nature of reality. At these scales, time becomes both precise and strange, a tool for understanding the cosmos and a window into the deep structure of the universe. Understanding time is no longer just a scientific curiosity. In the coming days, it could reshape how we explore the cosmos, how we compute complex problems, and how we perceive the universe itself. Spacecraft traveling near massive stars or black holes will navigate not just space, but time itself. Advanced quantum computers and AI may harness the subtle flow of time, solving problems once thought impossible. Faster, deeper, more precise measurements of time will unlock new technologies, new discoveries, and new frontiers. Time is the thread that weaves together the cosmos, technology, and human ambition. By mastering its nature, we may not only measure reality more accurately, but also transcend the limitations of the present and glimpse the future of the universe itself. If time isn't fundamental, what does that mean for reality? Are the past, present, and future all woven together, existing as one eternal tapestry? Do we move through time, or does time move through us? Perhaps the universe is a vast, timeless structure, and what we call moments are simply patterns in space and matter. The cosmos stretches before us, unfolding not moment by moment, but as a single, unified whole. As we gaze into the stars, we may begin to understand that the flow of time is a story our minds tell, and reality itself may be far stranger than we imagine. Time remains one of the universe's greatest mysteries, from the ticking of clocks to the bending of space, from the rhythms of our brains to the deepest laws of physics. Time touches everything, yet its true nature eludes us. We have glimpsed its secrets, from the tiniest quantum fluctuations to the vast cosmic fabric of space, and still much remains unknown. Perhaps time is a flowing river, perhaps a static structure, perhaps something even stranger. The journey to understand it continues. Curiosity drives us forward. Exploration lights the path. The universe is vast, beautiful, and mysterious. And as we search for answers, we discover more about ourselves and the cosmos we inhabit. The questions remain. The wonder continues. The adventure is just beginning. If you enjoyed this journey, like this video, subscribe to our channel, and explore more science.